Alright, so in this video, we're going to be doing part 2 of our Taylor and Maclaurin series practice. Okay, so we're going to have the problem, find the Maclaurin series for f of x equals cosine x. Okay, and now we're just going to have to follow our step-by-step process. Okay, we got to take our derivatives of f of x and try to find a pattern. Well, let's do that. We have that f of x is equal to cosine x. And f prime of x is going to be equal to, well, negative sine of x. F double prime of x is equal to negative cosine x. F triple prime is going to be equal to sine x. And, well, f to the fourth derivative is going to be equal to cosine x. Okay, that's just taking derivatives. Okay, we know that stuff. So now what we want to find is the nth derivative of f at x. And, well, do we know it? I mean, this is just, we don't know what that n is, obviously, right? That's why it's a variable. And we don't really know if it's going to be cosine or negative cosine or sine or negative sine, okay? So we don't actually know this. And that's going to be a little bit of a problem. We're going to have to take a little bit of a different approach, but that is going to be it for step 1 for now. Now step 2. We need to plug in x equals a. Maybe we'll have some luck and there'll be the nth derivative of f at a. We'll know what that is. Well, let's try that. Well, if we plug in x equal to a, we get f of, remember this is a Maclaurin series, so a is going to equal 0. Okay, this is the Taylor series at a equals 0. That's what a Maclaurin series is. We have f of 0. Cosine of 0 is 1. F prime of 0. That is going to be negative sine of 0, that is 0. Okay, your f double prime of 0, that's going to be negative 1, right? Negative cosine of 0, that's negative 1. F triple prime of 0 will be 0, negative sine of 0, or sorry, this is actually just sine of 0, that will be 0, and your fourth derivative is going to be 1. So you can see we're having the same kind of problem occur here. We're not going to know what our nth derivative of f at 0 is going to be. So what we're going to have to do here is list out our terms and see if there's anything that we can do like that. Okay, I'm going to show you that right now. And what we're going to start doing here, this is kind of our last-ditch effort. We're going to start listing out the terms of our series and hope that we see something. Let's start listing out the terms of our series. For our first piece, that will be our n equals 0 term. We plug in n equals 0 here, and we're just going to get f of 0. Okay, the 0 derivative of f at 0, that means we're not taking a derivative, and that's going to be f of 0. Now, 0 factorial will be on the bottom, and, well, which is 1, okay? You don't really actually need to include that, I guess. And you'll have an x to the n right here, and that's just going to be x to the 0 power, which is 1. Now, next, it'll be f prime of 0 over 1 factorial times x to the first power, okay, plus f, the double derivative at 0, over 2 factorial times x squared, okay? And then let's do a couple more here. We have plus f triple prime at 0 over 3 factorial times x cubed, all right? And so on and so on. Now we're going to plug in what we know this f of 0. We know that f prime is 0. We know the f double prime is 0. So let's plug those in. Here, well, we know that this will be a 1, right? Cosine of 0 is 1. So we're going to have a 1 over 0 factorial times x to the 0 power. We'll have plus a f prime of 0. Well, the f prime, that's going to be negative sine. Negative sine of 0 is 0. So this whole next term was going to be 0. Okay? What about next term? Okay, the next term, that's f double prime of 0. What is f double prime of 0? Well, that's going to be not negative sine, because that's the first derivative, and the next derivative will be negative cosine. Negative cosine of 0 is negative 1, so you're going to have a negative 1 over 2 factorial times x squared. Next, you'll have 0, okay, because that's going to be sine. You're going to have positive sine as your your triple prime. And, well, let's talk about the fourth piece right here. Now, I didn't do this fourth piece. It's pretty obvious to see though, this will be the fourth derivative at f of 0. And that will be over 4 factorial and multiplied by x to the fourth. Okay, well, the fourth derivative, well, that's just going to bring us back to cosine of x. And, well, plugging in our cosine of 0, that's going to be 1. So we're going to have 1 over 4 factorial times x to the fourth. Now, what we can do here is get rid of this n equals 1 term, get rid of this n equals 3 term, and we actually kind of start to see a pattern here. Okay, so what we're going to do is write this series in the terms of a different variable. Okay, our index is going to be now k equals 0 rather than n equals 0. Okay, we don't want to get confused here, so we're just going to switch the variable up. So ignoring the zeros here, I just kind of get rid of those zeros, and now we can actually start to write this series. Now we're going to start off with a -1. Okay, we know that we have an alternating negative, so is our first term. Our first term is positive. So, well, this is our k equals 0 term. And that means, well, we want this to be positive, okay? We want to be able to plug in k equals 0 and have this be positive. So what we're going to do is we're going to have an n here. We want odd terms to be negative. So that n does that. Now, next, what do we have on the bottom here? Okay, we can put something on the bottom. Or actually, you know what? Never mind. Let's do our numerator here, the x to the power. Okay. Well, this is our k equals 0 term. We get a x to the 0 power. Okay. What about the k equals 1 term? Well, now we get x to the second power. What about k equals 2? We get x to the fourth power. It's 2 times k. Okay, that's what our power is. So we get x to the 2k. Now this is going to be over our factorial. Okay, our factorial is the same thing. It's the same thing as the power. So we're going to have in the denominator a 2k factorial. Okay, and there you go. There's your series. All right. So now all that's left is to find the radius and the interval of convergence. Now, real quick, I'm going to change this back to n's now. The only reason why I switched it to k in the first place, if you didn't catch on that first time when I said it, is because I don't want you to get confused with the different series that we now had. Okay, we changed the series completely by getting rid of those the n equals 1 and the n equals 3 terms because they were 0. Okay, so we kind of had a new series here, but I didn't want to get you to get confused with the variables, so I had a k equals 0 instead of an n equals 0. Now we don't have that problem because we're not dealing with two series at once. Okay, so I'm putting it back into n equals 0. So we want to find that radius and interval of convergence. Let's use the ratio test here. We take the limit as n approaches infinity of a sub n plus 1 over a sub n. A sub n plus 1 is going to be let's forget about that -1. That doesn't really matter at all because that will just be, the -1 is just going to get canceled out by the absolute value. So we have an x to the, well, it's going to be a 2 times n plus 1, which is, so 2 times n plus 1, okay, a sub n plus 1. So we're going to have to put in a n plus 1 everywhere we see an n. This ends up giving us a 2n plus 2. And that will be over a 2n plus 2 factorial. This will be over a sub n, which will just be x to the 2n over a 2n factorial. All right, cool. So, well, now we can make this look a little bit nicer. And we get a x to the 2n plus 2 over x to the 2n, and that will be multiplied by a 2n factorial over a 2n plus 2 factorial. Okay, so now what are we going to be left with here? We'll have the limit as n approaches infinity of, let's take care of this, let's simplify this x down first. We're going to have an x to the 2n plus 2 over x to the 2n. That will just give us a x squared, okay, because the 2n's go away. So we have a x to the 2n here. And, well, this is the same thing, Okay, we can actually kind of rewrite this 2n plus 2 factorial. Okay, the 2n plus 2 factorial is the same thing as saying 2n plus 2 times 2n plus 1 times 2n factorial. Okay, that's the same thing. So the 2n factorials cancel out, and we're just left with that 2n plus 2 times 2n plus 1 on the bottom. So we have a x to the 2n over a 2n plus 2 times 2n plus 1. Now it becomes easy to see that as n approaches infinity, it doesn't matter what x you put in, that this limit is going to equal 0. Okay, that will equal 0 no matter what, which is less than 1. Alright, so what is your interval of convergence? Well, it's regardless of what n we put in. So your interval of it is regardless of what your x you put in. So our interval is from negative infinity to infinity. And that makes our radius of convergence infinity. Okay, so now you have your radius and interval of convergence, and you also have your Maclaurin series for cosine x. All right, so just to kind of recap what happened in this video, steps 1 and 2, we could not find out what our nth derivative of f of x or a was going to be. So we started listing out the terms, and we made a new series by getting rid of those zeros that happened in between. Okay, and that series is right here. That's what our new series became. Okay, now we found the radius and interval of convergence. That's right here. That was just by doing a ratio test and realizing that it doesn't matter what x we put in, we're going to get 0, and that of course is less than 1. So our interval is infinite, our radius is infinite, and that's going to do it for this video.
So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for sequences in series, the explanation video for Taylor and Maclaurin series, and the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.